This is my new Lego Pneumatic Engine, and it runs off of two large, actually extra large pneumatic cylinders, which are modified, and I have two pneumatic switches, which are also modified, and both of them are modified just to have less friction and also to have more airflow. So this actually does run better, and it runs pretty smooth that way. Some of the major changes to the second version is that I no longer have a big valve system that sits up at the top, and that old valve system was pretty sloppy, and the entire valve would kind of rock back and forth like that, and it would also just make the engine wobble a whole lot. And the other upgrade to this is I actually have gears in here that drives the valves. On the rear, I just have a big flywheel, which makes it run quite a bit smoother. On the bottom, I flipped the cylinders upside down because on my previous version, I had a bar going across right here. Actually, it's right here, and there were the hoses right there. And this engine is so torquey, it moves the entire thing up and down. And so it broke off the neck on this one. So I replaced it with some of Lego's flexible tubing, and it works really well now. So basically, I got rid of the old way of it sitting on top and risking the neck to be broken off. And I also just cleaned up the hose layout back here. So it's pretty flush instead of it going everywhere. So the crankshaft is the same design as I had previously, but these arms are quite a bit more sturdy, as I actually have it, what is equivalent to two, whatever these are called. All of a sudden I'm drawing a blank. Either way, two of them thick, so it's really stable. And on the also right here I have it so it's quite a bit more reinforced. And instead of having a little half piece like this holding this sliding arm alignment system, I have an actual full block here to hold it in place, which makes it quite a bit more stable instead of the whole thing rocking back and forth like that. Here's a closer look at the valves. They are just mounted directly to the bottom. So to power this, I just use a simple bicycle pump because it allows for a lot more airflow, and it as opposed to a basketball pump where you'd have to pump it really fast to get this running, just because since you're using two XL cylinders, it requires lots of air. This is right now running about 5 to 10 psi, something like that. And then here's 20. This time I did actually test the torque or the power of this engine, and what I did was I compared it to the basic PFXL motors and the normal battery box, a fully charged battery box. So the way I tested the power was to use this sort of arm. I have all of these, I think 16 tooth gears, can't quite remember off the top of my head, but they are all attached by friction pins, and then this arm so it can be put onto a scale. Once again, this is a PFXL motor with a fully charged battery, and here I'm going to turn this on. I'm going to set it on the table. Thank you for watching, and I actually did make a vehicle for the previous engine. which looks like this. It's in pieces right now because I had to tear the engine from that. And the previous engine, it just did not work well with this chassis. I actually really struggled to make a good chassis, and the video that I have of the recording of this is not great, and obviously I can't go back and remake the previous version just because, you know, I didn't have instructions for that. And also I would like to continue to tweak my current design more and more so it does become more and more powerful as well. So this right now is gone. I said I was going to try to make a vehicle for it, but I don't think it's going to happen. And there's my cat. Once again, thank you again for watching.